Okay, so we're going to continue from last time. And last time we showed that if we had two vectors, A and B, then their dot product was the length of A, the length of B cosine of theta, where if A and B were sitting here somewhere in space, then theta was the angle between them. So what we're going to show now, or let's actually do an example related to this. So what we're going to do is we're going to find the angle between the vectors 1, 2, 1 and 0, 1, -1. Okay, so we're going to use this formula right here that I underlined. And first of all, the dot product is 1 times 0 plus 2 times 1 plus 1 times -1, which is 2 minus 1, which is 1. The length of A is the square root of 1 squared plus 2 squared, which is 4, plus 1, which is the square root of 6. B is, the length of B is the square root of 2. So we have that A dot B, which is 1, is equal to the square root of 6 times the square root of 2 times the cosine of theta. So cosine of theta is 1 over root 12, i.e. theta is cosine inverse of 1 over root 12. And if you were on an exam and I asked this question, I would probably ask you to just leave it like this, because our final exam, which is the only written one, won't have calculators. But for the WebAssign and all, you'll definitely probably need a calculator. And if you punch this in, this becomes 73.22 degrees, rounded to two significant figures. Okay, so that's one type of example, finding angles between two vectors. But there's a special case of that occurs as follows, and we'll call it a little lemma because it's used so often that it maybe deserves a little bit of attention. So two vectors, A and B, are orthogonal. Now usually many people use the word perpendicular. Generally, the term orthogonal tends to be used more often in multivariable calculus. So two vectors A and B are orthogonal, i.e. they're perpendicular. And the way I'm going to write it is if and only if A dot B is equal to 0. So what does this if and only if mean? This means, this means two things. If A and B are orthogonal, then A dot B is 0. And if A dot B is 0, then A and B are orthogonal. They're equivalent statements. Okay. Just so you know, in general, just because you have a true statement from one, something implies the other doesn't mean the other has to imply the first part. So in this case, they're actually equivalent, and it's a simple proof. So first, suppose A and B are orthogonal. What does that mean? That means that the angle between them is 90 degrees, or pi over 2. Then A dot B is equal to the length of A times the length of B cosine of pi over 2, i.e., well, cosine of pi over, pi over 2 is 0, so this just means that this is 0. So that's part 1. Part 2, suppose A dot B is 0. Well, then we have 0 equaling the length of A, the length of B, cosine of theta. Dividing by the length, these lengths, we're assuming these vectors are non-zero. Everything here, we always assume the vectors to be non-zero. So cosine of theta then is just 0. So theta is cosine inverse of 0, which is pi over 2, or 90 degrees. Hence, A and B are orthogonal. Okay, so this becomes a simple way to show that two vectors are orthogonal. So just as another, again, a simple example, so show 1, negative 1, 1, and show A and B are orthogonal. So you would just show that their dot product is 0, and that's enough. And notice that A dot B, this is 1 times 2 plus minus 1 times 4 plus 1 times 2, and that indeed is 0. That's it. Hence, A and B are orthogonal. Whoa. A and B are orthogonal. Okay. So this is a nice way to show that things are parallel. And let me leave you here with an exercise. And so the exercises are the following. Vectors, following pairs of vectors, parallel, and shorthand for that is just 2 lines, orthogonal. Shorthand is the usual symbol for perpendicular, or neither. Okay, so here are the pairs. 2, negative 1, 3, and 1/2, negative 1/4, 3/4. This is 3, 1, 2, and 1, negative 2, 0. And last but not least, 2, 3, minus 1, and negative 2, 1, negative 1. Now, the only thing I will say in addition here is for the parallel part. So hint, parallel vectors are multiples of each other. So if they're not, the way to get neither is if they're not parallel, meaning they're not multiples, and the dot product is not 0, meaning they're not orthogonal, then you would have neither. So that's how you get neither. Okay, I'll leave you with this. We'll start the next video with this.